Welcome, lecture number 40 of part 1. More examples for replacement. But before I start, I will tell you, last time I considered almost same example. We have done replacement only at one point, that is left hand point. I don't remember which point. Okay, now a question with multiple questions, or see the question here. Replace the, why all these examples more and more I am doing is to give more practice. Remember, replace the given force system by an equivalent force and couple at, there are 6 questions here at A. See, independent question. See, question 1 dot is replace the given force system by an equivalent force and couple at A, over question. Second question, replace the given force system by an equivalent force and couple at B. That way, 6 points. I noted the answer there. This question I am not solving in detail because this is like parallel forces. Very simple. So I will solve briefly and give the answer. You practice. After this question, I will go for unlike parallel force system. And there I will write more details. So nobody can tell. He explained unlike parallel. First he solved one like parallel force system without explaining much. Then he solved an unlike parallel force system with more explanation, therefore not clear. How it is possible? If difficulty is there, leave it now. Go to the next question, then come back. Why? This is easier. I want first, because systematically, first like, then unlike. So like is for you. Okay, start. Now, solution, class. Now onwards, I have decided not to tell same thing again and again. People who cannot go through all the classes and make all the necessary notes, that make all the points, and if they cannot make it, then they are not fit to study from me. My way of teaching is tell everything systematically, not a single doubt should come. For those who are regular and dedicated. I use the word dedicated. If you are not dedicated, right now leave the class. Right? I will tell that way. See, it may look little harsh. Nobody will tell that way. I will tell that way. I give value for education. Okay, start. Class. To replace a given force system by a single force and couple at any given point, first find magnitude of the resultant force and direction. Line of action not required because we are replacing. Okay, now magnitude like parallel forces easily you can find. I will tell how to find magnitude. Then find algebra direction. By looking only you can tell the direction. See this question. For all the 6 questions, resultant force equal to 100 Newton down. Why? 30 plus 40 plus 20 plus 10. 100 Newton down. Okay. If not clear, not fit for engineering studies. Okay. Then direction down. So magnitude direction over. Now usually if they want resultant, you find line of action. Remember, resultant and replacement are different. So many people they mix it up. Sometimes people tell find the resultant force and couple. Sorry, they do not know the concept. I will tell them in front of them, you do not know the concept. You tell replacement. Resultant cannot be a force and couple. Remember, it is nonsense. Resultant will be a force. If it is not a force, it can be a couple. If that also is not there, equilibrium, no resultant. Replacement is by force and couple. In the notes, this statement with the validity and more explanation, 5-6 pages I am going to write. Why? There I give, see, notes means those who have more faith in me, they want each and everything. Therefore, there I will give more details. Problems also. Now onwards I decided to do more and more questions in the notes. Class, not very much limited. Unnecessary waste of time in the class I will not make now onwards. I decided. Otherwise, class will become too long. Someone will tell, sir, I am depending only on the class. Yes, I am covering everything. If you still want more, no other way, you have to go for the notes. Okay. Start. Find magnitude of the resultant force, 100 Newton down. Then where you want to replace, find algebraic sum of moment of the given force system about that point. Use sign convention. Again I will tell, consider clockwise positive. If the answer is positive, it is clockwise. If answer is negative, it is anti-clockwise. But later remember, something else is there when you go to equilibrium. There it is not this way. Plus minus means something else there. One class full board I will write. Left hand side calculation, right hand side equilibrium. I will tell you later. Finding something is left hand side, sign convention. Finding unknown based on equilibrium is sign convention. People will they will mix that one. I see that mix up will not come. Okay. Now, when you write the final answer, write without what? Sign. If you get clockwise positive, mark clockwise couple. If you get negative, mark anti-clockwise couple. Okay. Then, words I will dictate here if you want. Okay, start here. So, resultant for then algebraic sum of moments of given force system about A equal to, I am not calculating, see here, right? Clockwise positive, 30 into 0 plus 40 into 4 plus 20 into 9 plus 10 into 6, 15, correct? Yes, 15. It will come plus, I noted down, it is already there, plus 490 Newton meter, I first thought kilonewton, yes, Newton, okay, Newton meter. Therefore, sigma m about A is no plus 490 Newton meter clockwise, right here, that much clockwise, over. Now, over. Therefore, replacement of given force system by an equivalent force and couple at A will be as shown below. A downward force of 100 Newton and a clockwise couple of 490 Newton meter. If you want to write words, the given force system can be replaced by a single downward force of 100 Newton and a clockwise couple of 490 Newton meter at A, over. Okay, now, second question. You should see, those who are serious, should not do what I am doing. I am not learning, I am teaching. Replacement of given force system by a couple at B. B. This will remain same. Moment about B you take now. See here. Take moment about B. This point. Clockwise positive. If I tell minus means it is anti-clockwise, I won't tell every time. See earlier I will tell clockwise, therefore plus. I won't tell. Now onwards, if I use plus means clockwise, minus means anti-clockwise. Minus 30 into 4, 40 into 0, plus 20 into 5, plus 10 into 11, over. Answer will come plus 90. Plus 90. So, it is 90 Newton meter clockwise is the answer. Therefore, remember now, at A how much I got? I will make a small note here. I got down 100 and clockwise. This is not for you, it is for me. It is for me. Don't see there, 490. Therefore, answer is replacement at which point? At the point B will be, see, B is somewhere here, remove it. See, if it is A is here, if it is D here, then B is somewhere here. Then it is, red color is, okay, I want red color, okay, okay. It is a downward force of 100 Newton and a clockwise couple of, how much? 90 Newton meter is the answer for B. I will make a small note here for my reference. Clockwise 4, yeah, unnecessary. It is clockwise 90, sufficient. Okay. That is for my reference. Okay. Now, question number 3. Replacement at C. This will remain same. Moment will be moment about C. Minus 30 into 9, minus 40 into 5, 20 into 0, plus 10 into 6. It will come minus 410. Answer will come about C. About C will come minus 410. Means what? It is 410 that much anti-clockwise. Therefore, replacement at C. See, A is here, D is here. A and D are the endpoints. Somewhere here, point C is there. Replacement is downward force of, I forgot last time, change it A. See, when I changed the statement last time, you write B. Okay, now write C. This is for people who are trying to find the mistake. He told everything, but still he maintained A. No, change it to B earlier. Now C. How much? 100 Newton and anti-clockwise couple of 410 Newton meter over. A, B, C. A and D are end points. I want that line. A and D. Okay. Now, fourth question. Independently solve. Replacement at D. This will remain same. Take moment about D. See, I forgot change it last time. First time A, second time I changed here, I forgot here. Second time you write B, just now you have to write, which one? C also over. See, these are all called print mistake. Now write D. Okay. When you calculate moment at D, see, minus 30 into 15, minus 40 into 11, minus 20 into 6, answer will come minus 1010. I got the answer there. Minus 1010. So, 1010 Newton meter anti-clockwise is the replacement at D. Okay. Change it. Now C is not required. D. What is the answer? D is downward force of 100 Newton and anti-clockwise couple of 1010 Newton meter is the replacement at D. Anti-clockwise. Okay. Oh, I forgot the answer is there. Anti-clockwise 410 of 90 here, 410 here, 410 at C 410, anti-clockwise 410 at D 1010 anti-clockwise. Okay. Now, fifth question. Replacement at E. This will remain same. Once same is you have to write it if you are serious. Equal to. Take moment about E. Where is E? E is here. See, E is here. Start. Plus 30 into 2 plus 40. E is outside point. Plus 30 into 2 plus 40 into 6 plus 20 into 11 plus 10 into 17. Answer will come minus clock plus 690. Correct? Huh? 100 into 200 more. Oh, correct. 600. I can check the answer. Plus 690. So, moment about E is 690 Newton meter clockwise. So, replacement at E. One more sketch you are right. At E will be AB you still maintain. AB is here. Your E point is somewhere here. See, here is your E. The replacement is downward force of 100 Newton and how much is? Clockwise couple of 690 Newton meter. That also over. Any changes? No. 690 over. Last point answer is here how much? Here 690 clockwise. There 1310 anti-clockwise. Okay, I noted the answer. Lastly, sixth question. Suppose examination means only one they will give. Replacement of given force system by an equivalent force and couple at F. F is somewhere here. F is here. Take moment. Minus 30 into 18 minus 40 into 14 minus 20 into 9 minus 10 into 3. That will come minus 1310. It will come at which one? F point. At F is minus 1310. So, sigma m about F is 1310 Newton meter anti-clockwise. So, the replacement will be, now E is not required. At F, replacement is, further you go by 3 meter, it's the point F, a downward force of 100 Newton, anti-clockwise couple of 1310 Newton meter. question is completely over. Completely over. Now, just to understand, do one thing. Make a note. Just to understand, 7th question. Just to understand. Replacement of given force system by equivalent force and couple at EFG, where the point G is between B and C, comma, at, that is how much B and C is, at 1.5 meter from B. Okay, one extra question for you. Okay, leave it. So now do one thing, mark that point, extra point. Which point? Somewhere here. 1.5 from B, between B and C means it will be here. Extra point. I will use a color for that point, red color. Okay, I'll use some other color, not red. I will use a green color for that point. Okay. G here. G, this is 1.5 meter. If that is 1.5, this will be 3.5 meter. Okay. Now start. This will remain same. G. Algebraic sum of moments of the given force system about G equal to, see, correct, clear, about G, I will tell you, minus 30 into 4 plus 1.5, 5.5, minus 40 into 1.5, plus 20 into 3.5, plus 10 into 6 plus 3.5, 9.5, that G point. Answer will come, I will calculate. Because this point, just now I thought a point. How much I told? I told minus 30 into 5.5 minus 40 into 1.5 plus 20 into 3.5 plus 10 into 9.5. Minus 60. It will come minus 60. Therefore, G point, sigma m about G equal to how much? 60 Newton meter anti-clockwise. 1 minute now. How much I told answer? About G is anti-clockwise 60. Okay, now 1 minute. I'll check the answer. How I check, you don't bother. I can check the answer. B, what is the answer? 90. 90 minus 100 into 1.5. Minus 60, correct. You never bother these things all. What I have done now, that is, these are all you should understand yourself. I used the result at B and shifted to that point. Never go for all these things, asking for trouble. These all you learn when you reach that level. When you reach the level, try it. Okay, now, completely question over. Now make a note. One note. I am dictating. There is one more approach if you want. Right here. There is one more approach if you want, but better not go for it. See, I will dictate now. If a force system is given, if you have to replace by equivalent force and couple at any one point, see, usually in a question, only one point is there. Simply what you do, find the resultant force, magnitude and direction only, don't locate line of action, and then find algebraic sum of moment of all the forces about that point where you want to replace the given force system by single force and couple. That algebraic sum of moment, whatever you got, itself is what? Itself is resultant couple. That is the best option. Now, but there is one more option. Technically, one more option is there. What you do is, see now, right here. Remember, note, only for those who can understand this one. Somebody will tell, sir, I am getting confused. Don't study it then. Someone will tell, sir, too many methods, sir, confusion. Why no confusion for me? Sir, you know, okay. So, if anybody thinks this is becoming confusion, just leave it. Don't continue. Don't tell me confusing. You should not use the word confusing. If you're confusing, don't go for it. If you understand, I will tell one more approach. This is very useful if you are replaced by multiple points. See, here you are replaced by A, B, C, D, E, F and G also. One extra point. Total 6, 7 points they want. So 7 times you took moment, but you can eliminate all those calculations. Very simple way you can do it. So actually in a question anywhere you will not require 7 points. You require only 1 point. In that case, what I told procedure is the best procedure. So this is only for those who want to learn more concept and who can afford these things. See, I will tell what to do. First, I will tell procedure. Procedure. That is another option. Another option. First, completely forget about replacement. Go back to resultant. Find the resultant force completely. Means find the resultant force completely. Magnitude, direction and line of action. Very neatly mark the resultant. That means the complete given force system can be replaced by that single force which you marked by red color. Oh, that's all. Then where you mark resultant, from there shift it to wherever you want. Wherever you want, shift. So 7 questions you can do in a single stretch now. See now. I told you, meant for those who can understand. Others not advisable. But guaranteed answer will come same. See now. Okay, now all over. Yeah, sorry. F I have not given answer for you. Okay. I have not given answer for F. Write it. I forgot. Last time, see, you write that G point. Down 100 and anti-clockwise. How much I told? 60 Newton meter. You write last time. I forgot to write it. Okay. Now see. New approach. First, forget that replacement. Forget that replacement. Go back to earlier cases. Go back to earlier classes. Find, see, red color, resultant force completely. That is magnitude, direction and also locate line of action. Okay, start. Okay, then I don't need. First I'll do this one. Let us first do this much. Start. Old classes now. Start. Statement. This is a parallel force system and it is a like parallel force system. Therefore, resultant force is directly equal to sum of all the forces. No sign required. So, resultant force for given force system, which is a like parallel force system, that is R equal to, you can do one thing, directly take downward. Why? You know downward. Plus 30, plus 40, plus 20, plus 10 equal to plus 100 Newton. Therefore, resultant force equal to 100 Newton down, over. Right here, we got magnitude, we got direction. Next, to locate, don't see other things now, see only the forces. To locate line of action of resultant R. Let resultant R cut AB line at a point X, comma, at X from A, any reference point A, as shown. These are already over earlier. See, A, B, other things are not required. Somewhere here resultant cuts. R equal to 100 Newton. This point is X. This is X. To right side you are taking X. Now, to get X, First of all, I should not tell. I should give only answer. Why? So many questions are solved. Apply Varignone's theorem. Varignone's theorem, right? Algebraic sum of moments of the given force system about A equal to moment of the resultant force R about the same point A. I won't write. Take clockwise positive. Start. Algebraic sum here. Take clockwise positive. 30 into 0 plus 40 into 4 plus 20 into, don't see the G point now. 30 into 4. 30 into 4 plus 40, 30 into 0 plus 40 into 4 plus 20 into 9. 9 plus 10 into 9 plus 6 is 15 is left hand side equal to resultant R, that is 100 Newton into X. It is a clockwise, so plus. You get the value of X in meter. I have to calculate it. Actually, I don't have to calculate. I will, without seeing, I will tell the answer now. If you want, 4.9 meter. How means you don't bother? Because I can see the answer there. There are so many concepts in structural engineering, in engineering mechanics, lot of concept where if you understand, these are all nothing. Okay, I will check for you. 40 into 4 plus 20 into 9 plus 10 into 15 equal to divided by 100. 4.9 meter plus 4.9. Okay, plus 4.9. Plus 4.9 meter. Okay, now one statement you have to write. We consider resultant to right of A. Right of A. By distance X. Answer came plus. Therefore, correct. It is to right of A. How much? 4.9 meter. A to B is 4 meter. Therefore, the resultant will be slightly after B, but before C. Even it is before G only. See, from A 4.9, from B you have to go to 0.9 meter. Therefore, let me clearly show the resultant first. Okay, I will tell you now. Therefore, I will write here now, see. Therefore, the statement right here. Therefore, resultant force for given force system is as shown below. As shown below. Okay. Start. Point A here. See, to understand correctly, this is the point D. This is the point B, 4 meter. This is the point, the 5 meter. This is C. This is D. Okay, actually, one force here, one force. How much force not required? This way. This is C. If you want distances, this is 4 meter. This is 5 meter. This is 6 meter. It is 4.9 means, see, it will be here. This is the resultant force R equal to 100 Newton. From A to that distance is 4.9 meter. If you want, from there you can calculate this distance now. How? From total, I don't know, 15, subtract 4.9. From 15, subtract 4.9. Minus 4.9. 10.1 meter. Okay. 10.1 meter. Resultant is completely over. Now do one thing. Draw, see, now go for that replacement. Replacement by replacement of the given force system by equivalent force and couple at 7 different points. Now do one thing. For that one procedure, neatly mark the force system. First, draw a neat sketch so that very easily you get the answer. Draw a neat sketch first. Because sometimes if sketch is not neat, when you solve, you will make mistakes. Wrong number will come there. So it is very important, draw a neat sketch. Mark first A here, see. Here. A from this side. A is not writing. Okay, change the pen. This will do. A, B, how much? 4 meter, 5 meter, 6 meter. Okay. This is your A, this is your B, this is your C, this is your D. There's a force here of, actually this force is not required. C, A, B, C, D over. Okay, see, there's a force, light line. There's a force here, there's a force here, there's a force here, there's a force here. But all these forces are not there. Now all these forces are replaced by a single force of resultant equal to 100 Newton. If you want, from A it is 4.9 meter, or from D it is, how much I told? 10.1 meter. And now do one thing. Mark all the point replacement. You want replacement at A, at B, at C, at D. Also you want at E. Mark the point E. Distance from EC is how much? This is 2 meter. This is 4 meter. This is 5 meter. This is 6 meter. Also one more point called light line. F here, which is how much? 3 meter. 3 meter. And one more point G is here. I use the same color. Which one? Green color. One point G is here. G. The G is from here to here is how much they told? 1 point, it out of scale. Okay, out of scale. 1.5 meter. If that is 1.5, this will be 3.5 meter. Okay. Now see how fast you can do. Okay, now answer I will give, I will get the answer. Sketch will remain same. Okay, now start. Therefore, what? So, see, at all the point, at all 7 points, that is A, B, C, D, E, F and G, equivalent force remains 100 Newton down. Equivalent force remains same. Why? Net force, but couple will change. But equivalent couple will change. Couple will change. That is, when you replace the given force system by a single force and couple, you can either call replacement by an equivalent force and couple. Some people call single force and couple. At different point, at all the point, the force is 100, but the couple will change. How to get the couple? Find moment of the given force system about that point. But you know that moment of the given force system about any point equal to moment of resultant about the same point. Therefore, instead of wasting time finding moment of given force system 7 times earlier about 7 different points, you just find moment of the resultant force about that point. So, moment of R, resultant R about A equal to, see here, about A is 100 clockwise, is plus 100 clockwise positive. Clockwise, actually now clockwise sign also not required. No, not required. See, 100 into 4.9. Sign convention not required. 100 into 4.9 equal to 490 Newton meter clockwise. See, clockwise. Right. Therefore, equivalent force and couple at A will be a downward force of 100 Newton and a clockwise couple of 490 Newton meter. Correct. If you want to put a sketch, then moment of resultant R about B. See, single step you are getting equal to 100 into this distance. This is 4.9. This is 4. So this will be 0.9 meter. 100 into 0.9 equal to 90 Newton meter clockwise. Therefore, equivalent force and couple at B will be 100 Newton force down with a clockwise couple of 90 Newton meter. Correct. Then, right. Moment of resultant R about C equal to, see, C is here. See, this is 10.1. This is 6. This is 6. So, moment about this point is from 10.1 subtract 6. What you get? This from force 100 into, see here, from here to here is 10.1 minus 6 is 4.1, but equal to 410 Newton meter, no plus minus, about C, anti-clockwise. Therefore, equivalent force and couple at C will be downward force of 100 Newton with anti-clockwise couple of 410 Newton meter. Correct, see? 410. Next. Moment of one after other you have to write, not this way. Write one calculation, write the statement. Moment of resultant are about D equal directly 100 into 10.1 equal to 1010 Newton meter, see, anti-clockwise. Therefore, equivalent force and couple at D will be downward force of 100 Newton and anti-clockwise couple of 1010 Newton meter. Moment of resultant are about E equal to, about E, see here, 100 into, this is 4.9, this is 2 meter extra, 6.9. 100 into 6.9 equal to 690 Newton meter clockwise. Therefore, equivalent force and couple at E will be downward force of 100 Newton and a clockwise couple of 690 Newton meter. Moment of resultant are about F equal to, here, 100 into, this is 10.1, this is 3, 13.1 equal to 13.1. I should write neatly. 13.1. 1310 Newton meter. It is anti-clockwise. See, about F anti-clockwise. Therefore, resultant equivalent force and couple at the point F equal is downward force of 100 Newton and anti-clockwise couple of 1310. Lastly, moment of resultant are about that new point. Which point it is? G. Extra point G. See here. G is here. This is 1.5. See here. This is 4.9. If this is 4.9, this is 4. Remember, this distance will be 0.9. That much mathematics. When this is 0.9, this is 1.5. This from G to this force will be 1.5 minus 0.9 is how much? 0.6. Correct. 0.6. This is 0.6 meter equal to 100 into 0.6 equal to 60 Newton meter. Point G is here anti-clockwise. Correct. I got 60 only. Correct. I got 60 only. Therefore, equivalent for the given force system, equivalent force and couple at the point G, or if you replace the given force system by a single force and couple at G, it will become a downward force of 100 Newton and anti-clockwise couple of 60 Newton meter. Okay. I first thought today I will do this like parallel force system, brief solution, and very fast I will tell second one. But second one I told in detail because by revision. Actually, resultant marking I should not have explained. It's already known to you. Still, I thought better tell everything. Therefore, what I will do is now I will extend slightly, no problem. Otherwise, the class will go for another 1 hour or 45 minutes. Too lengthy class nobody wants, I know it. A class around 30 minutes is the most ideal. Up to 40 tolerable. Above 1 hour, unless it is required, I will not go for it. Therefore, no problem. So, next class, I will go for replacement of a given force system by same force and by single force and couple for unlike parallel force system and also for a coplanar force system. Of course, how to find moment you know it. So, after I finish which one? Unlike parallel force system, coplanar force system, little fast I will do. Why? How to find moment you already know it. We had done a master example. See, Suppose a coplanar force system. After resolving, you get like this. How to find moment? We have done a question where so many terms were there. So this is nothing. So I think next class I can wind up this part 1. Thank you. Attend now. Completed will be completed in the next part. Next lecture. Lecture 41.